needs any info, check Martin. He's helping you a lot. That being said, let's move because I think she's ready. I don't see her yet, but I know she's in the backstage. So if she pops up and gives me the nod that she's ready to rock, she's already waving. So that's amazing. She's ready to go. I already said her name. She was also active in the chat, which I really appreciate. Next speaker is going to talk about techniques for maintainable Quarkus applications. And she said we're going to talk about calm, noisy loggers, avoid memory leaks, and better control over your endpoints. I have no idea what that means, but it sounds super interesting. And she's already laughing. So I love the energy. Without further ado, she is Anna Maria. I'm going to try to Mihalceanu. Do I pronounce it right? Something. Saying like just leave the name. I'm just going to call you Anna Maria, and you can do the last name I'm going to try after the presentation. There you go. You're a Java champion, developer advocate at Red Hat, if I'm not mistaken, and you're a co-founder of the Bucharest Software Craftsmanship Community, which is great. So I'm not going to take any more of your time. Anna Maria, you're ready. I'm ready. The crew is ready. People are still going on in the chat, which is great. Take it away. The floor is yours, and have fun.
Thank you. So hopefully everybody sees my screen. I'm moving this and moving to here. And let the show begin. So thank you everyone for joining Techniques for Maintainable Quarkus Applications. I am Anna Maria Mihalceanu, but for short, I'm Anna. It's way easier to say my name like this. I have become a Java champion earlier this year and currently working as a developer advocate at Red Hat. I like to share my experiences and my experiments, in different technical meetings and with different communities. And I like to support the communities as well. You can find me on Twitter at Ambra1508. And please feel free to use the chat today because I'm going to answer all of your questions even after the session. I am looking over the chat, so I'm looking at it over the chat afterwards, and I will reply to all of your questions, regardless how beginner or advanced they are. For Java or Kubernetes, because I also love Kubernetes. Forgot to mention that as one. So those being said, today's topic, maintainable applications. Well, probably you associate maintenance with words like bug fixing. I mean, that's the thing that comes to a developer's mind in the first place. Like I'm associating that, and I was associating that for a lot of time with bug fixing. But growing in the career and becoming an architect, I realized that bug fixing was one of the things when we talk about a maintainable software. When the code is evolving, well, the problems become with maintainable code are like how easy it is to switch a functionality, how easy it is to put new things without, messing up the rest. And by easy, meaning easy for the developers to implement that in terms of time or in terms of, let's say, cost for the business. And that's why the reason for the talk today, like maintainable applications with Quarkus, because, well, Quarkus has been for some time in the market. And let's look to a little bit more advanced things with Quarkus. And like Albert Einstein said, well, we need a new approach in terms of solving the problems and not use the same techniques that we used to have when we created. So speaking about solving problems, for I think the past 10 years, the technical communities have embraced the microservices architecture for various reasons. And one of them was maintainability, of course, because, well, microservices, well, they come with deployment independency, they come with fault isolation, zero downtime, granular scaling. So this is the nice story that you get when you're looking like to adopting a microservices architecture. You got these things and many more things. But behind the scenes is actually a little bit more complex than that, because these, at least these four aspects, they do solve some problems regarding maintainability. I mean, thanks to deployment independency and fault isolation, bug fixing can be thought and can be solved easier. Or replacing functionalities. Well, since we have microservices and small applications that are independently deployed, it's easy to replace functionalities. And when it comes to like your endpoints receive different workloads, you can granularly scale them. So things should be easier, right? But new maintenance challenges have occurred once you're moving to this kind of architecture. And I'll try to summarize a few of them in today's talk. So one of the things that I personally observed was that having details when troubleshooting is very crucial. But now, thanks to the microservices architecture, you have logs at application level, at container level, at orchestrator level. So you will have different areas where you're getting logs. And let's just say that aggregating logs can be done with different services and with different, most of the time, infrastructure tools. And you put them all together, but getting the good information that can help you when you're digging stuff is another story. So in today's talk, we're going to look at how to tailor those logs with Quarkus without polluting the logs and actually not exposing any sensitive information. Then if you're using caches, one untested caching strategy, well, it's an inferred memory leak. And testing caches has been something that I think a lot of teams have struggled during time. Like, hey, we're doing this caching strategy. How do we know it's good? How do we know it will be okay on the long term? And last but not least, well, underestimating the production load or the behavior is very difficult to estimate how things are going to become in the bigger future. But also in today's talk, we're going to look at how we can trim those things and we can approach those things to have them under control. So why Quarkus and why not something else? Well, first of all, because we speak about fixing or replacing things. Speed is important for us developers to do all these things, to do our tasks, our jobs. So Quarkus for developer experience, because it comes with live reload, with continuous testing, and with dev services. And I'm going to use all these three today because I don't have that much time at hand in order to show you everything. So these three are going to help me a lot. Then speaking of memory leaks, one of the causes for memory leaks in the past were using directly the prepared statements and forget to close some statements when interacting with the database, for example. And while Hibernate and JPA help you a lot when interacting with the database, there's also coming on top of these Panache that helps you and abstracts even more some work for you as a developer. Now, another challenge I had when starting with Quarkus a few years ago was thinking how easy it would be for me to adapt to the ways that Quarkus is working. And one thing that made me feel comfortable when using Quarkus was the Spring API compatibility. And I discovered during time that, well, the Spring API compatibility is even better when using Spring with Quarkus, because I can benefit from early detection of dependency injection errors at compile time instead of build time. So that's one thing. And then integration capabilities. We all the time need frameworks that can be able to integrate with a lot of other dependencies and extensions. And Quarkus is bringing a lot of extensions there for this reason. In today's app, because we need to maintain an app together, we're going to look at the Personalized Facts app, which is a microservice based on Quarkus. This is the scope that we're going to manage today. Now, the Personalized Facts app is exposing an API for consumption for other parties. And like in real life, the Personalized Facts is consuming some information from an externally managed API, the CatFacts API, which is a real API, by the way. And is processing those information pretty much like probably everyone is doing. You're processing those information in order to get into the form that the end users would like to see those informations, or that other applications would like to consume that information. And because sometimes going back and forth to something that's not managed by you, it can be costly, and you're kind of depending on that. Sometimes it's better to store some of that process data that you're offering to your end users in your own persistent store. So this is going to be the scenario that we're going to look into today. And we're going to maintain today with a few techniques. And those being said, let's code. By the way, in today's session, my microservice is built with Java 17. So Hope you don't mind that, but do not worry. The GitHub that I'm going to share with you contains also Java 11 version. So this is the CatFacts API. Cute, right? This is where we're going to consume information. And let's look at it and open the app. I forgot to mention something. So CatFacts API, well, it's a free API, and like any free API, sometimes it has downtimes. But we're going to work with it regardless of this. So let's first look how the application got built. Now, if you're wondering how the application got built, the personalized facts was actually resulting from here, from code.quarkus.io. Just give it my name and put personalized facts and selected like 10 extensions. I know it sounds like a lot, but the actual result is a very small application in terms of memory footprint and all. So because I'm exposing an API, I've used the REST easy JUXRS with the serialization from JSONB extensions. I'm consuming an API, so I need a REST client. I'll be using some caching, so I'll be using the cache extension, the caffeine one from Quarkus. Since I store data in PostgreSQL database, well, I need a JDBC driver, and I'm using the Hibernate RM with Panache on top of that, so that I don't do the prepare statements thing myself. And I'm using Micrometer in my tests today, so I also added Micrometer. And because, well, there's an issue, because I want to see the endpoints, I'm using the SmallRye Open API because I want to see some Swagger endpoints and to interact better with my endpoints. And also, well, I needed to add full tolerance because, as seen earlier, my CatFacts API is not working as expected, unfortunately. So let's go to the IDE and see what we can make of it. To introduce you into the atmosphere here, the microservice itself is pretty straightforward. Well, since it's consuming some information from an external party, it has the fact service interface, which was annotated with register REST client. So that, sorry, just give me a moment to make it bigger, so that this can be seen as a REST client and the part that can consume from somewhere the information. And I just put the /facts to say that I'm consuming from the CatFacts API. And with Quarkus, that's the only thing that I need: an interface, a register REST client, and maybe the path if it has an additional path. Some of you are like now asking themselves, where do you put the URL? So the URL is going to come here at org.acne.experiments.external.facts service, np-rest URL, and that's it. So that in order for consuming those endpoints from the CatFacts API. Moving forward, this service is actually being consumed by the personalized facts resource. So we're exposing to our users the information in the way we want as developers, and as actually they are expecting it. But since, like probably in real life, you're getting information from somewhere, you need to transform them. I've created my own DTOs. And for my DTOs, I've used the nice features of Java 17, which are the sealed classes and, well, also records. By the way, if you want to work with DTOs, using records is one great thing to do that. So that's one aspect of the Java 17 usage part. So this is the consumption part. And if we're moving forward, we need a way to store the information, right? So we said that we're going to store information in our node database. And those being said, let's make a database configuration here. And this is dev. I'm going to also make it for production. So I'm using a PostgreSQL everywhere. But the things are not going to be the same in production and in dev. So because probably in production, I'm not going to, drop and create. I'm going to do none because I want for my not generate all the time. So this means that my configurations should be different across dev and across production. And what I can do with Quarkus is use profiles for different apps, just prefix this with dev and this one with prod, for example, so that I can make a difference between the two. And another good thing, so this might be probably is going to be import.dev, and this one import minus prod. Well, in production, maybe I don't know the username, probably is coming from the pipeline. So I'm going to give here a variable called Postgres user and maybe a default val, call it Postgres. Here, Postgres pass. And here, I can give a Postgres URL. So one advice for maintainable applications with Quarkus would be to use the variables, especially when you're having different application profiles. And now that we're having these starting, let me just start my app here in the terminal and say mvn quarkus.dev. So this one is going to start my app in developer mode. And okay, having no database here. The reason why I didn't configure a database is because there is going to be a default database started by the dev services with Panache, and that is going to take care of that for me. So in dev mode, I don't need to define a database when I'm working with Quarkus. I just can go ahead like this and define my database only for production. So no more worries for me in terms of that. My app probably has started. And let's go to the browser and see localhost 8080. Even though that I'm consuming stuff from a not working API or an API that doesn't work that well. So let's try my API via my Swagger, say cat execute. And you can see it's taking a lot of time and is not that nice. And probably is going to give an error at the end because I didn't protect my API didn't make it resilient. So let's add some resilience to that. But besides, because we're still here in the configuration part, and before going to the resilience, I talked about noisy loggers. So I want to make a distinction with loggers between dev and production. And the way that I can do that is by using Quarkus log.min level for dev, for example, and I can say here it's going to be finest. And here, Quarkus log.category, because I'm actually caring what my application is going to say, and do the Quarkus Acme experiments and also set min level debug because, well, in dev, I want to be able to debug. But it is not the same for production, right? I don't want to have these things in production. So prefixing is one thing, and making sure that I'm not having the same things. So I can say here in production, I can put info and info, and here info as well. And here, let's put the dev and the dev. So now I have a clear way to distinguish my logs. I'm not gonna interfere a lot. So my production is not getting polluted in the same way as I'm doing it for my local development. And you can see here things are not working because, well, the catfacts API is not working. So let's make it work. In order to make the catfacts API work, there are a few ways to do that. So one thing, you can work with retries. So you can say, I want to retry maximum 4 times, like every, let's say, 250 milliseconds. Or you can add timeouts. So timeout after 250 milliseconds. They very fine work together. Or you can also use circuit breakers. So the circuit breaker annotation is really, really fine. So for example, okay, this circuit, close the circuit in 75% failure ratio is reached. But you can also add a fallback because if things are not working, you also need to give something to your users. So what you can do, you can either use a fallback annotation with method fallback and say, I have a method fallback here, I think. Oh yeah, fallback facts. Fallback facts, and that's solved. But another way on how to fix the things with fallbacks is by actually defining your own class. So facts fallback.class. Maybe this one is suiting you better. So there are different ways to make this maintainable on the long term. And create inner class. And this one implements fallback handler. So what I need to do is, because I need to offer my consumers the same thing I would have given them if it was the real service, I need to return the same type of return like the regular method, right? And then let's return and return set dot of empty fact. So now my application would be bulletproof against these kind of issues with the resilience. But moving forward, I need to also do some performance part and show you how things are performing. So I do have another API available here. I made my own API, so do not mind me switching because I want to show the other parts with a working API, not just one that returns you the defaults. So I'm just replacing this and clicking here to reload my stuff. And now things are looking great. See, you see here that it says test paused. What this means is actually the continuous testing is being stopped. And right now, the tests are, one of them is failing, so probably something is it still needs some fix. Okay. And we need to look into it. But moving a little bit forward, one of the things that I was telling you in the presentation is like how to look at the performance of your endpoints, what to choose. And one thing that as a developer, probably you're thinking of like all the time in implementation, like, okay, so what should I return and show to the end users? Should it be like a synchronous or asynchronous response? And in order to solve that issue, I have coded two endpoints that are, having the same query param, which is type, but one of them returns information synchronously, the other one asynchronously. And I want to, see their performance. And what I'll do, I'll go to the unit tests and use timers to assist my performance in in seeing which one is working better. So I'm going to create two timers, one for sync, one for async, which are going to like record what's going on different endpoints, and then I'm going to do the timer sync record. So I'm going to do 5 invocations and record what's going on that one and record the total time. And then I'm going to do timer async invocation and record, of course, the same. So the same type of test so that nobody's like having doubts that, I'm trying to not be the real thing. So one test is failing. What test is failing here? I have a lot of problems here, it seems. Log configuration step, not entity manager. I know why. I forgot something. My tests also need something. Complete test. This is my complete test profile. Yes, so for the tests, I don't need the real database. I can use also an in-memory database. Now reload. And looking back to my tests, okay. Schemized node due to changes in personalized test facts. Stop this one. Start it again. Because I want this to run successfully when we're seeing it. So I want for Quarkus to run the things for me. Okay. Okay, and now run the tests. So now the personalized facts resource are running. and the compare response time was run and is all working perfectly. So all my tests are passing now. Now I was telling you about, the measurements of caches. So let's implement also cache. And the part where I identified that, need a cache and would be great would be adding a cache result annotation on the method that gets facts by ID. So when I'm getting facts by ID, I am using the animal facts cache by using the cache key parameter for fact ID. So that's what I'm caching. I'm caching facts by their IDs. And in my application.properties, I also need to configure my cache to work and give the name here. So I'm going to say animal facts. This is the name of my cache. The initial capacity is 1 and the maximum size is 5. And I also need to test if this one, is working as expected and is doing the right thing with my application. So I'm going to go back to personalized resource task, and we can measure the cache, and if the cache is behaving as expected or I'm reaching the maximum value of it. So what I can do, I can make my own. So I need to retrieve my cache first. And the way to retrieve my cache is by getting it from the cache manager and say here, animal facts. And I'm creating a gauge, micrometer gauge, where I'm storing the cache size. And I need to do some tests, of course. Again, I need to record a few things with my cache. So I'm making 5 invocations because I said the maximum of my cache is going to be 5, right? So I'm making 5 calls, 5 times calling, and do some invocations there on different IDs for the facts that I have. And then I need to measure the information, measure how things were there. So what I'm doing after, recording thing, I'm getting the cache, the gauge from the registry. I am getting the measurements that the gauge got in my test. And then I need to check what the measurements recorded and what is my expectation. So my expectation is to have, even though that it was run 5 times, to have 1, 2, 3, and this one repeats, 3 things cached. So let's do this. And now the tests are running again. And you see, should measure cached facts as sync is passing successfully. So this is one way how you can measure your caches. Now, another thing that I want to bring to your attention is that when you're having long-running operations, like when you're initializing your app and your app is starting, for example, I'm executing this at the startup of my application. I need to insert some things in the database of my startup of my application from the service. Then I'm annotating with that startup, but I don't want this to be happening in dev or any other profiles of my app. So what I did, I annotated with if build profile named prod, so that I can, instruct my app that, okay, when you are with the profile of prod, you do this. But in the rest, I don't want you to do this long-running operation. So, and if we come back to the presentation and finish this, some takeaways for you would be to refine your log details per application and package need. Like I showed you, you can build a resilient application by using the 4 magical annotations, retry, circuit breaker, fallback, and timeout. You can validate the performance of your endpoints by using timer, as I did, or follow the capacity of your caches using gauge in your integration tests. So those tests that I've showed you are really doing and testing the real stuff. And you can annotate with this build profile some long-running operations that you need to be executed only in a certain application profile, like probably in an integration test or load tests. Thank you. This is where you find the code. Please scan the QR because actually it's containing the presentation. And in the presentation itself, you have some links to some useful links where you can find out more about how Quarkus performance is measured, more about logging, more about dev services and what other dev services are available, and also some books that can help you when learning Quarkus or when transitioning from Spring to Quarkus, or how you can use your Spring knowledge with Quarkus. Thank you, and back.
To Marnik. That is me. Thank you so much, Anna Maria, for that presentation and live demo.
Welcome.
Yeah, and also you. It's so cool to see how you kept your cool. Like the test was running, and there was something going on, which is perfectly normal. It's happening live, and I was like, "What's she's gonna do? What's she gonna do?" And it was like watching a show, and she's like, "I have a problem. Let me see what the problem is." I know, bam, you fixed it. Loved it.
Well, I love working with Quarkus and been working with it for some time. So yeah, pays.
Yeah, you got that cool about you, which is really nice. Also, before you started, like I think code with me is the answer to the question of my jet brain. I'm having the suspicion, seeing everybody wants to code with me. It's going back. If you have questions for Anna Maria, put it in the chat. Take into account I have a certain delay, so I'll refresh a couple of times. Because it was so interesting, I also have my questions while people maybe pose questions, and that is that does continuous testing work even when integrating Spring in the application? That's what I want to know.
Yeah, it's working still there. So continuous testing is available all the time. I pressed R. So when you're in dev mode and in the terminal, I just pressed R because you see those those indicators there saying what to press, and I pressed R and it worked. And there are a lot of cool features that came with Quarkus too that help you even more as a developer in case you forget things. For example, I forget a parameter once to code it in the application properties, and Quarkus told me like, "Hey, you forgot to initialize this." So it's really useful there, especially the continuous testing parts. It's just doing things and compiling things for you while you're coding. And this is probably, if you're like watching the terminal while I was coding, you could have seen some red stuff because it's doing that real time and all the time. So, and it's a very useful feature.
Yeah, there you go. We should need that with everything. Like when you're fixing the sink, it's like, what am I doing wrong? And now you have to go to Google, and then Google says, I also have no clue, but because that particular sink you don't have. But now you have in Quarkus, it just goes along, which is really cool. Like I said, I'm looking on the right. And then the last, we're looking also at the time because I have to give people time to switch the streams if they want to. Of course, more than welcome to stay in this stream. You already touched upon it in your presentation. You also share a bit more about the dev services and how these are going to boost productivity.
So the thing is that as a developer back in the day, I had an issue because all the time to do a setup, and probably you will know this, not just microservices related, all the time related, you have to do a certain setup, right? Set up a database, set up something. And dev services work not only for databases, for example, like when you're using a persistent store, but also work with Kafka services, for example. So when you are like trying to do code something with Kafka, they are there to help you. Or when you're trying to use OpenID, so when you're trying to do some security stuff, there's also dev services available for you. So you don't need to spin up a lot of stuff on your computer, so less, because they're not consuming as much as, you know, a regular setup, and you don't have to do all the readmes. They're just doing things in the background. One thing you should know is like you should have your Docker started, because they're running test containers, and actually they're starting a container in the background for you. So, and they're doing all the magic for you. Don't worry, everything's safe. And you can also turn them off if you're like annoyed and you still want to do your own setup.
There you go. Nice, thank you for that. I get the feeling that it's really there to help you, and it's all kumbaya and happy. So you should use it. That's the message right there, and I love the way you brought it. Giving them time to switch. Anna Maria, thank you so much for. How do you pronounce your last name now? Because we didn't touch upon that.
Mihalceanu. It's Mihalceanu. Yeah.
Mihalceanu. I was far away from that. Mihalceanu.
Yeah, now it's perfect.
Nice. So Anna Maria Mihalceanu, give her a digital applause. Thank you so much for the presentation.
Thank you for having me. Enjoy the rest of the conference.
Will do, and keep joining in the chat and connecting with people.